Good day, ma'am. In this presentation, we will be talking about chemistry of water pollution. Under chemistry of water pollution are topics including water pollutants and their sources, water pollution in rivers, lakes, and estuaries, and also groundwater pollution. So, what are the sources of water pollution? Their sources of water pollution can be categorized into two categorization: the point sources and the non-point sources. Under point sources are domestic sewage and industrial waste. They are called point sources because they are generally collected by a network of pipes or channels and conveyed to a single point of discharge into the receiving water. In short, point sources are those sources that ang waste or ang mga pollutants nga iyahang gina-discharge kay wala na daghang pangagian niya diretso na wala na kanang giagian, or in short ang mga pollutants kay diretso na sa receiving water or sa stream. The second categorization is the non-point sources. Under non-point sources includes urban and agricultural runoff. Urban and agricultural runoff are characterized by multiple discharge points. In short, ang non-point sources, ang mga pollutants or ang mga waste kay dagan pag-agian nga mga discharge point before siya ma-adto sa receiving body or sa receiving water. Non-point pollution from urban stormwater, and in particular stormwater collected in combined sewers that carry both stormwater and municipal sewage, requires major engineering work to correct. Kasagaran daw sa mga pollutants or waste gikan sa mga non-point sources kay kailangan og mga major engineering works para ma-correct siya. So these are different types of pollutants. First, oxygen demanding material. Oxygen demanding materials in domestic sewage come primarily from human waste and food residue. Anything that can be oxidized in the receiving water with the consumption of dissolved molecule oxygen is termed oxygen demanding material. These naturally occurring organic matter such as animal droppings, crop residues, or leaves that get into the water from non-point sources contribute to the depletion of dissolved oxygen. The second type of water pollutant are nutrients. Nitrogen and phosphorus, mao ni siya ang duha ka nutrient nga kailangan nga dapat minimal lang or kanang dili siya pasubraan or excessive ang maabot sa water. Problems arise when nutrient levels become excessive and the food web is grossly disturbed, which causes some organisms to proliferate at the expense of others. Because tungod sa mga nutrients, naay mga organisms nga proliferate in expense sa others. For example, excessive nutrients often lead to large growth of algae, which in turn become oxygen-demanding material when they die and settle in the bottom. Some major sources of nutrients are phosphorus-based detergents, fertilizers, and food processing waste. The third type are pathogenic organisms. Microorganisms found in wastewater include bacteria, viruses, and protozoa excreted by deceased persons or animals. When discharged into surface waters, they make the water unfit for drinking. If the concentrations of pathogens is sufficiently high, the water may also be unsafe for swimming and fishing. So, ang mga pathogenic organisms, dili lang siya delikado sa mga isda, pati na pod sa mga tao kay because of those pathogenic organisms, ang water may be unfit for drinking. And next type is the suspended solids. Organic and inorganic particles that are carried by the wastewater into a receiving water are termed suspended solids. When the speed of the water is reduced by the flowing into a pool or a lake, many of these particles settle to the bottom as sediments. Ang mga organic and inorganic particles nga madala sa wastewater sa mga sa anything nga nasagol sa wastewater kay consider na siya nga suspended solids niya kung if the speed of the water is slow, these organic and inorganic particles may settle to the bottom and mahimo na siyang sediments. As excessive sediment loads are deposited into lakes and reservoir, the usefulness of water is reduced. Next type are salts. A problem arises when the salt concentration in normal fresh water increases to the point where the natural population of plants and animals are threatened or the water is no longer useful for public water supply. High concentration of salts are discharged by many industries causes high salt levels in urban runoff. Ang problem sa salt kay if ang concentration niya kay mo taas, mo mag-threaten na siya sa population of plants o animals nga naa sa water and pwede na po siya nga dili na siya useful sa public for water supplies or irrigation. Pharmaceutical and personal care products or PPCPs. These are a class of compounds that are applied externally or ingested by human, pets, and other domesticated animals. They are released to the environment through the disposal of expired, unwanted, or excess medications to the sewage system by individuals, pharmacies, or physicians. So, ang kaning PPCPs, these are compounds nga kasagaran gina-discharge sa mga sewage system nga pwede siya nga delikado sa not only sa plants nga naa sa water but also the animals and also for the humans because these compounds may contain ingredients that are harmful and these disposed products may also be expired or unwanted. PCP such as deodorants and sunscreens can be washed into our waterways during bathing, washing, and swimming. Some PCPs are also used as pest control agents. Kasagaran sa mga examples of PCPs or pharmaceuticals nga makita sa wastewater kay ang common prescription and veterinary drugs such as beta blockers. Example na kay metoprolol o propranolol. Next are endocrine disrupting chemicals. The class of chemicals known as endocrine disruptors or EDCs alter the normal physiological function of the endocrine system and can affect the synthesis of hormones. Some naturally occurring EDCs such as 17B estradiol, that is both a naturally occurring estrogen and a synthetic estrogen used as a method of birth control, are excreted into the wastewater. Ang kaning endocrine disrupting chemicals, mao ni siya mga chemicals nga naga-alter sa normal function sa atong mga endocrine system. Nya maka-affect na siya sa production of synthesis sa atong hormones. For example, kani daw 17B estradiol nga naga-affect sa atong naga-affect sa mo ginahimong method of birth control niya kasagaran siya ginadispose sa wastewater which is also harmful. EDCs can also target tissues where the hormones exert their effects. Next type are pesticides. Pesticides includes herbicides, insecticides, and fungicides. Herbicides to kill weeds, insecticides to kill insects, and fungicides to kill types of fungi. The most commonly occurring pesticides found in water were primarily those currently in use, whereas those found in fish and sediments are the organochlorine insecticides such as DDT that were heavily used decades ago. So, self-explanatory naman siya kay we all know that pesticides contain harmful compounds na delikado siya not only to the water, not only to the organisms nga gina-control ano niya, but also organisms nga naa sa water nga maka-receive ani nga compounds. Next pollutant is heat. Although di siya gina-consider nga gina-recognize nga pollutant, those in the electric power industry are well aware of the problems of disposing of waste heat. Higher temperatures also increase the rate of oxygen depletion in areas where oxygen-demanding waste are present. So, pag high ang temperature, mo increase ang rate sa oxygen depletion niya. We all know that if mag-deplete ang oxygen, maapektaran ang mga organisms nga naa sa water. Water pollution in river. The impact of pollution on a river depends both on the natural of the nature of the pollutant and the unique characteristic of the individual river. So these are some of the most important characteristics of a river: the volume and speed of water in the water flowing in the river, river's depth, the type of bottom, and the surrounding vegetation. Ang water quality management for a particular river must consider all these factors. Mao nang ang river kay susceptible siya to different types of pollutants such as sediment, salt, and heat, while other rivers can tolerate large inputs of these pollutants without much damage. Total maximum daily load. It specifies the maximum amount of pollutant that a water body can receive and still meet water quality standards. In addition, it allocates pollutant loadings that may be contributed among point and non-point sources. It is computed on a pollutant by pollutant basis for a list of pollutants similar to those. Additional categories include acids and bases measured in pH, pesticides, and mercury. So, ang total maximum daily load mo ni siya isa li siya ka type of computation nga i-compute niya ang maximum amount of pollutant nga ang water maka-receive, pero dili siya mo lapas or it still meets the water quality standards. Effects of oxygen-demanding waste on a river. The introduction of oxygen-demanding material, either organic or inorganic, into a river causes depletion of the dissolved oxygen in the water. This poses a threat to fish and other higher forms of aquatic life if the concentration of oxygen falls below a critical point. So, we all know that ang oxygen is a very important in a water. Kay almost all organisms in the water kay nagadepende sa oxygen. If ang oxygen ma-deplete or maggamay, it will threaten the lives or it can pose a threat to fishes and other forms of aquatic life. To predict the extent of oxygen depletion, it is necessary to know how much waste is being discharged and how much oxygen will be required to degrade the waste. Organic oxygen-demanding materials are commonly measured by determining the amount of oxygen consumed during degradation in a manner of approximating degradation in natural waste. Biochemical oxygen demand or BOD. If the oxidation of an organic compound is carried out by microorganisms using organic matter as a food source, the oxygen consumed is known as a biochemical oxygen demand, or the BOD. BOD test. The BOD test is an indirect measurement of organic matter because we actually measure only the change in dissolved oxygen concentration caused by the microorganisms as they degrade the organic matter. Solving BOD, or biochemical oxygen demand. Formula to be used. BOD subscript T is equal to LO times 1 minus E raised to the power of negative KT, wherein ang LO is often referred to as the ultimate BOD, that is the maximum oxygen consumption possible when the waste has been completely degraded, and ang K kay reaction rate with a unit of D raised to the power of negative 1, and T time. Example, if the BOD3 of a waste is 75 mg per L and the K is 0.150 D raised to the power of negative 1, what is the ultimate BOD? So, kabalo naman ito sa formula, i-plug in na nato ang mga given, makakuha na ta og ibagi na itong mga given, which is ang BOD 3 kay 75, ang LO mo na siya ang unknown 1 nya 1 nya minus E raised to the power of negative K times T, which is 3 nya kamang tag-answer nga 0.645 LO nya. Ato na siyang i-equate LO, mahimo na siyang 116 or 120 mg per L. The ultimate BOD. The maximum oxygen consumption possible when the waste has been completely degraded. The maximum BOD exerted by the waste. Oxygen depletion is related to the both ultimate BOD and the BOD rate, or K, while the ultimate BOD increases in direct proportion to the concentration of the degradable or organic matter. The numerical value of the rate constant is dependent on the following: the nature of the waste, the ability of the organisms in the system to utilize the waste, and the temperature. So, ang diri nga ang ultimate BOD daw, ang BOD rate constant kay related sila. Kay ang ultimate BOD daw increases in direct proportion to the concentration of the degradable organic matter. The nature of the waste. Not all organic compounds can be degraded at ease. Simple sugars and starch are rapidly degraded and will therefore have a very large BOD rate constant. So, sa nature of the waste daw, nagadepende ang pagdegrade sa waste kung unsa ni siya klase nga compound. For example, ang simple sugars, dali lang man siya ma-degrade, so it has a large BOD rate constant. The ability of the organism in the system to utilize the waste. Any given microorganism is limited in its ability to utilize organic compounds. As a consequence, many organic compounds can be degraded by only a small group of microorganisms. Giingon diri nga ang BOD daw, ang BOD rate daw kay nagadepende sa kung sa ability sa organism sa water or sa system to utilize the waste. For example, naay microorganisms nga kailangan lang og small group of organisms nga dali ra sila makadegrade og waste or organic compounds. Yan na po yung ban nga bisan pagdagan na kay sila dili ka mo sila makadegrade og organic compounds. The temperature. Most biological processes speed up as the temperature increases and slow down as the temperature drops, because oxygen utilization is caused by the metabolism of microorganisms. the rate of utilization is similarly affected by temperature. So, ang temperature daw, ang temperature affects most biological processes niya. Kung pagtaas daw ang temperature, mo speed up daw ang process, pag baba po, mo drop ang process. Nitrogenous BOD. Nitrogenous BOD, in many cases, has at least as much impact on dissolved oxygen levels. Modern wastewater treatment plants can routinely produce effluent with CBOD5 of less than 30 mg per L. A typical effluent also contains approximately 30 mg per L of nitrogen, which would mean an NBOD of about 237 mg per L if were discharged as ammonia. So, kabalo naman ta nga ang ammonia is not poses a threat on water. Other factors affecting DO levels in rivers. Number 1. Multiple point sources can be handled by dividing the river up into reaches with a point source at the head of each reach. A reach is a length of river specified by the engineer on the basis of its homogeneity, that is, channel shape, bottom composition, slope, and so forth. Number 2, some rivers contain large deposits of organic matter in the sediments. Number 3, these can be natural deposits of leaves and dead aquatic plants or can be sludge deposits from wastewater. So, maka-affect po sa DO level ang mga large deposits of organic matters sa sediments. And the third factor is aquatic plants can also have a substantial effect on DO levels. During the day, their photosynthetic activities produce oxygen that supplements on aeration and can even cause oxygen supersaturation. So, ang aquatic plants daw also plays a role in affecting the levels in rivers. Effect of nutrients on water quality in rivers. Nutrients can also contribute to deteriorating water quality in rivers by causing excessive plant growth. So, ang nutrients daw maka-affect sa water quality sa river in a way that these nutrients causes an excessive plant growth, and some plant growth is desirable since plants from base of the food chain and thus support the animal community. However, excessive plant growth can create a number of undesirable conditions such as a thick slime layer on rocks and dense growth of aquatic weeds. Effects of nitrogen. There are 3 reasons why nitrogen is detrimental to receiving body. First, in high concentration, NH3 negative and is toxic to fish. Second, NH3 in lower concentration and NO negative 3 serves as nutrients for excessive growth of algae. The conversion of NH4 positive to NO3 negative consumes large quantities of dissolved oxygen. So, mo to siya yung mga reason sa anong na-epekto ang nitrogen sa receiving body. Effects of phosphorus. The major deleterious effect of phosphorus is that it serves as a vital nutrient for growth of algae. If the phosphorus availability meets the growth demands of the algae, there is an excessive production of algae. So, ingon dire, ang phosphorus daw kay nag-contribute sa growth sa algae niya. We know that if an algae die, they become an oxygen-demanding organic material as bacteria seek to degrade them. Water pollution in lakes. Oxygen-demanding waste can also be important lake pollutant, especially when the waste is discharged to a contained area such as a bay. Pathogens are of particular concern near bathing beaches. Biological zones of a lake. Lakes contain several distinct zones of biological activity largely determined by the ability of light and oxygen. The most important biological zones are euphotic, littoral, and benthic zones. Euphotic zones. The upper layer of the water through which sunlight can penetrate. All plant growth occurs in this zone. Euphotic zone, this is the zone nga kanang makapenetrate pa ang sunlight niya, diri nagatubo ang mga plants. Littoral zone. The shallow water near the shore in which water-rooted water plants can grow. The extent of the littoral zone depends on the slope of the lake bottom and the depth of the euphotic zone. So, there are also instances nga ang littoral zone can extend deeper than the euphotic zone. Benthic zone. The bottom sediments comprise the benthic zone. As organisms living overlying water die, they settle to the bottom where they are decomposed by organisms living in the benthic zone. There is a benthic zone, diri mo siya ang bottom part niya. Ang mga plants nga nasa taas ma-decompose diri nga zone because of organisms that are present. Example are bacteria. Lake productivity. The productivity of a lake is a measure of its ability to support a food web. Algae from a base of this food web supplying food for the higher organisms. A lake's productivity may be determined by measuring the amount of algal growth that can be supported by the available nutrients. So, ang productivity of the lake daw kay pwede ito siya measure through the growth of algae and can be supported by available nutrients. Oligotrophic lakes. Oligotrophic lakes have a low level of productivity due to a several limited supply of nutrients to support algal growth. As a result, the water is clear enough that the bottom can be seen at considerable depth. So, ang oligotrophic lakes daw, na siya ay a low level of productivity because limited lang ang supply nga makasupport sa algal growth. Because ay tungod ani ang water the water is clear enough nga pwede na ta makita ang kung unsa ang nasa ilalom. Eutrophic lakes. Eutrophic lakes have a high productivity because of an abundant supply of algal nutrients. The algae cause the water to be highly turbid, so the euphotic zone may extend only partially into the epimelion. So, ang eutrophic lakes daw, kabaliktaran po siya sa oligotrophic lakes. Sa eutrophic lakes, na siya high productivity kay abundant siya. High productivity of algal growth kay because it is abundant of supply of algal nutrients. Mesotrophic lakes. Lakes which are intermediate between oligotrophic and eutrophic are oligotrophic and eutrophic. Although substantial depletion of oxygen may have occurred in the hypolimnion, it remains aerobe. Senescent lakes. These are very old, shallow lakes which have a thick organic sediment and rooted water plants in great abundance. These lakes will eventually become marshes. So, eutrophication. Eutrophication is a natural process in which lakes gradually become shallower and more productive through the introduction and cycling of nutrients. Thus, through the process of eutrophication, ang eutrophication is a process nga nagapa-shallow sa lake, and a less productive lake may become a more productive through the introduction of cycling of nutrients. Tungod aning eutrophication, in some instances, oligotrophic lakes gradually pass through mesotrophic, eutrophic, and senescent stages, eventually filling completely. Other lakes may have been eutrophic form from the day they were formed if nutrient levels were high at that time. Cultural eutrophication is caused when human activities speeds the processes naturally occurring by increasing the rate at which sediments and nutrients are added to the lake. Thus, lake pollution can be seen as the intensification of a natural process. So, in a cultural eutrophication, naanay role nga gina-play ang mga humans. They through human activities, ginaspeed up niya ang process sa naturally occurring process, sa process sa rate sa sediments nga ma-add sa lake. Thus, lake pollution can be seen as the intensification of a natural process. This is not to say that eutrophic lakes are necessarily polluted, but that pollution contributes to eutrophication. Algal growth requirements. All algae require macronutrients such as carbon, nitrogen, and phosphorus, and micronutrients such as trace elements. For algae to grow, all nutrients must be available. Lack of any one nutrient will limit the total algal population. The algal growth requirements naga-require ang algae para mo tubo siya or mo be more productive. Naga-require siya og macronutrients such as carbon, nitrogen, and phosphorus, and micronutrients such as trace elements. In carbon, algae obtain their carbon from the carbon dioxide dissolved in water. Nya ang nitrogen daw usually in a form of nitrate comes from external sources by way of inflowing streams or groundwater. Nya ang phosphorus kay also originated from external sources and is taken up by algae in the inorganic form of PO4 -3 and incorporated into organic compounds. During algal decomposition, ang phosphorus mabalik siya to inorganic form. Micronutrients trace element. The quantities of trace elements required to support algal growth are so small that most fresh waters have sufficient amount for substantial algal population. Control of phosphorus in lakes. Because phosphorus is usually the limiting nutrient, control of cultural eutrophication must be accomplished by reducing the input of phosphorus to the lakes. Once the input is reduced, the phosphorus concentration will gradually fall as phosphorus is buried in the sediment or flushed from the lake. Other sources of phosphorus: municipal and industrial wastewater. So, ang municipal o industrial wastewater contains phosphorus in a way nga ang mga tao nagagamit o mga products nga na phosphorus contains, for example, detergents. If we throw laundry waste to the wastewater, it can contribute to the increase of phosphorus in the receiving water. Septic tank seepage. A second source of phosphorus is the septic tank seepage. The shores of many lakes are dotted with homes and summer cottages, each with its own septic tank and a tile field for waste disposal. As the capacity of the soil to absorb phosphorus is exceeded, and any additional phosphorus will pass on into the lake, contributing to eutrophication. Third source is agricultural runoff. Because phosphorus is a plant nutrient, it is an important ingredient in fertilizers. As rain important man siya ingredient sa fertilizer if ever magulan, madala ni siya sa mga streams o lakes makakontribute na siya sa increasing of phosphorus in bodies of water. Acidification of lakes. Pure water is slightly acid, so nakakontribute siya sa acidification of lakes. High aluminum concentration are often the trigger that kills fish. Aluminum is an abundant in soil but is normally bound up in the soil minerals. Other factors that affects the susceptibility of a lake to acidification are the permeability and depth of the soil, the bedrock and the slope and the size of the watershed, and the type of vegetation. The control of lake acidification is related to the control of atmospheric emissions of sulfur and nitrogen oxides. Water pollution in estuaries. An estuary is formed along the coastline where fresh water from rivers and streams flow into the ocean. It is a place of transition where fresh water mixes with salt water. Estuaries are influenced by tides. So, ang mga estuaries daw, ano siya kanang where rivers and ocean meet, or sa tawagan ay basta na siya na magsugat ang dagat ug ang sapa. The mix of salt water and fresh water combined with the diurnal cycle of tidal wetting and drying and changes in salinity makes the estuary ecosystem extremely complex. Because kanang diri man nagsugat ang dagat ug ang sapa, mo nagausab-usab yung salinity nya, mo siya nagapa-complex sa ecosystem sa estuaries. Nya, just like any other surface water, estuaries are subject to a plethora of pollutants. Although the technologies and policies that serve to manage the water qualities of lakes and rivers also apply to estuaries, the management of water quality is complicated by the number of political jurisdictions that touch on the estuary as well as the competing need of organisms that live there. So, the current management of water quality kay although daw ginaparehas lang ang water quality management sa lake o rivers, gina-apply pud siya sa estuaries, nagapon day mga ay dili gyapon daw siya completely basta di kasi kay naa mga organisms nga naara sa estuaries niya wala day sa lakes o rivers susceptible to pollution. Fifth, groundwater pollution. Groundwater by its very location has a large measure of protection from contaminants that are found in surface water. However, once groundwater becomes contaminated, its location and low rate of replacement with fresh water makes it difficult to return it to a pristine state. There are two major sources of contaminants sa groundwater. First one is the uncontrolled releases of biological and chemical contaminants, and second one is saltwater intrusion from over pumping of wells. First source, uncontrolled releases. Uncontrolled releases comes from a variety of sources. Just like discharges from improperly operated or located septic systems, leaking underground storage tanks, improper disposal of chemical waste, spills from pipelines, leaking landfills, and leaking retention ponds or lagoons. Ang kaning mga water-soluble chemicals are likely to move vertically down through the soil to the aquifer and migrate with the water as shown in the figure. The second major source of groundwater pollution is saltwater intrusion. Freshwater aquifer near oceans or above saline aquifers may become contaminated with salt water when water is pumped from wells that draw water that is too close to the freshwater saltwater interface. Because seawater is heavier than freshwater, it will form a saltwater wedge in aquifers that drain into the ocean. When fresh groundwater is underlain by saline water, pumping a well in the freshwater will cause the interface to rise below the well. This upconing is in response to the pressure reduction on the interface that results from the drawdown of the water table around the well. If the well screen is close to the saline water or the pumping rate is too high, salt water may be drawn to the well. That's all. Thank you.